Okay, so welcome back to 16.1 part 2. We are talking about isosceles and equilateral triangles today. Now, isosceles triangles, as we know, have two congruent sides. That makes them an isosceles triangle. All right, so you see the two markings. Those tell you that it is side AB that is congruent to BC, making this an isosceles triangle. Now, the two congruent sides, we have names for them. They're called legs. So this is a leg and this is a leg. We call those the legs. And those are kind of important. So let me color them in so that we can draw attention to those legs of the triangle. This angle right here that is between the two legs, we call that the vertex angle. Now, it's not always at the top. Sometimes they rotate the triangles and do different things. So we just know that the legs come together at the vertex angle. Now, the side opposite the vertex angle, so we're at the vertex angle, we go directly opposite, that is going to be called the base. Attached to the base, let me really quickly write base. Attached to the base on either end, we have base angles. All right? Now, those base angles are going to be congruent because, I'm going to see if you guys can see this for a minute. All right, I've done this before, I think, in class. I've used my hand as little sides of a triangle. And then if you think of the side between my fingertips as the third side of the triangle, so it's kind of imaginary, but you can kind of see it there. And then between my two palms right there, I'm going to actually zoom out so you can see it a little bit better. So I have between my palms right there is going to be an angle. So if you look at this angle right there, okay, and I make it bigger, then I know that the side opposite, the ones between my fingertips, gets bigger. That side gets longer, the greater my angle between my palms. And then if I make my angle smaller, then the side opposite there gets smaller as well. So we know that the side opposite an angle is related to that angle. So the legs that are congruent, because they're the exact same measure, then the angle across from them must also be congruent because it's making the same measure of angle across from, or side across from the congruent angle. So if this angle is this big and this angle is this big, then the sides across are going to be the same measure. If they're the same measure of angles, they'll be the same measure of sides. And if they're the same side measurement, then the angles opposite them will be the same. So it happens both one way and the other. And those are the important parts that we have when we're dealing with isosceles triangles, is that we have two legs and a base. Okay? Across from the base is the vertex. Across from each leg are base angles, and the base angles are congruent. And of course, we know that isosceles triangles have the legs congruent also. So with that, we have the base angles theorem and the base angles converse. Now, if you remember, first of all, I just want to turn your attention back to a while ago when we actually were in class, and we talked about conditionals, and that we have an if and a then. And if this is true, then this is true. And we called those conditionals. And those conditionals have converses, such as if I say, if it is a cow, then it will moo, right? If it is a cow, then it will moo. What follows the if is the hypothesis that it's a cow, and then what follows the then is the conditional that it will moo. Now, if I switch those two, I have something called a converse. And that converse switches the hypothesis and conclusion. So then it would say, if it moves, then it is a cow. And that's your converse. So the original theorem is, if it is a cow, then it will moo. Its converse is, if it moves, then it is a cow. And the same thing goes for these two theorems. One's the theorem, the other is the converse. So the hypothesis and the conclusion are stated in the first one. If two sides of a triangle are congruent, so that's what follows the if, two sides are congruent, then what follows the then is opposite, the angles opposite those sides are congruent. And then you notice on the converse, if the two angles in a triangle are congruent, then the conclusion is the sides opposite those angles are congruent. So they're basically just converses of each other. This one states if two sides are congruent, then those angles opposite are congruent. And that's what we mean by angles opposite the sides, is because whatever the side is, the angle is the one that you go directly, follow your finger directly across from the angle. From the side, you have the opposite angle, and vice versa. From the angle, we have the opposite side, just kind of when I like when I use my hands and show you that what happens with the side opposite the angle. It's important to note that. So the converse says that first the angles are congruent, then the sides, second the sides opposite them will be congruent also. And those are the two theorems. And they're pretty useful. I'm gonna actually just do example 5 because that's what we deal with for isosceles triangles. So the example says if triangle RST is isosceles, find the measure of angle S. So what we note here is that these two are the legs. They're the legs because they're the congruent sides. This one would be the base, by the way. Now this angle is exactly opposite this side. This angle is exactly opposite that side. And those two angles then are base angles and therefore congruent to each other. So if they're congruent to each other, we would set up that 15x minus 31 must be equal to 9x plus 11. So if you subtract 9x from both sides, you get 6x minus 31 is equal to 11. Add 31 to both sides, you get 6x is 42. Divide by 6, your x is 7. All right. Now, looking back at the problem, did it ask us to find x? No. It asked us to find the measure of angle S. Did I need x to do that? Yes. So it's a good thing I solved for x. Now, how do I find S? Well, I don't even have an expression for S. So what I will do is find these angles and then subtract their sum from 180 to get S, right? So plug 7 in for one of them. I'm going to pick this one because it's a little easier. So 9 times 7 is 63 plus 11 is 74. So this angle is 74, and so also then, will this angle be 74 because they're the base angles. So let's see, what is that? 8 and 7 plus 7 is 14. 148 is the sum. That's what we have so far. And our top angle is 180. The whole sum is 180. So our top angle will be 180 minus 148. So, let's see, 180 minus 2 times 74 is what I'm going to do to make sure I get the right answer, and that is going to be 32 degrees. All right, so the measure of angle S, which it asked us to find, is 32 degrees. All right, that's one half of the lesson. Now we're going to talk about equilateral triangles. Now, equilateral triangles. A triangle is equilateral if and only if it is equiangular. So that means all three angles are congruent. So if the measure of angle A is equal to the measure of angle B, which is equal to the measure of angle C, then we know that the side AB will equal the side BC will equal the side AC in measure. So if all three angles are equal, then all three sides are equal. All right, and then we have a converse again, just like we did with the isosceles triangle. We have a converse, and that is we switch the sides with the angles. If all three sides are congruent, then all three angles are congruent is the converse. So the measure of angle A is equal to the measure of angle B is equal to the measure of angle C. So if all three angles are congruent, then of course the sides opposite them will all be congruent. And if the sides of a triangle are all congruent, all three sides, then all three angles will be congruent. And that's the definition of an equilateral triangle. Now, we do know one thing about the angles, and that is that the angles all add to 180. And if all the angles are the same, then we only need to know that they're all the same. And if they're all the same, we can come up with the measure of the angles. So if we take 180 and divide by 3, we get 60 degrees. We also know in an equilateral triangle, all angles must be 60 degrees, right? All right, so for example, if we have a triangle KLM, which again, we're going to have to draw ourselves, which is fine. KLM, just draw a triangle and mark it. And we know K is congruent to L. So K is congruent to L, and I'm just going to arc them with an arc. That tells me that the two are congruent. If those are congruent, by the way, let's go ahead and use our theorems and note that across from K is a congruent side, and across from L is a congruent side. So those are the two sides that are congruent. And then it tells us LM is 7x minus 37, so we'll mark that. KM is 3x plus 23, and asks us to find x, all right, on the measure of each side. So, I don't know that we're going to be able to get this side, but we can get these two sides. Whatever the case, these are congruent sides, so we can set 7x minus 37 equal to 3x plus 23, and then solve. If we subtract 3x, we get 4x minus 37 is 23, and then if we add 37 to both sides, we get 60, 4x equals 60, so x must be 15 if you divide by 4. All right, now KL, we have no way of telling. We can't determine that. We don't have enough information. If they told us it was an equilateral triangle, we would know it, but it doesn't. It only tells us we have two congruent angles and therefore two congruent sides. So anyway, we can find the other two sides and they're congruent, so we can just pick one. And I'm going to pick the bottom one. So 3 times 15 plus 23 is 45 plus 23 or 68. So both sides are equal and they'll be both 68. All right, in units. Alrighty, well, do 16.1. Good luck with it. You will have to download the packet, but you can do that. No big deal. Or you can come pick it up at the school. It's in the front of the office. I have been getting some questions. How do I turn it in? What do I do with that? What if I can't take pictures and upload it? You can always come and pick it up, and then you can just drop it off. If you're going to drop it off, though, they ask that you call first. Call them and let them know you're coming because somebody from the counseling office has to put on gloves and then go out and meet you and grab it. So whatever. That's a way to turn it in if you don't want to take a picture and upload it or if your internet's slow or whatnot. All right. Have a great day.